All right, so we need to finish worksheet 2B. I think in a great rush yesterday I finished this question, yes? Okay. This was the really icky kind where you had to move one radical over the other side and square both sides, and then it turned out you had to do it again. All right, and we can do another one of those tomorrow or whenever we have practice time. All right, this lesson is on this worksheet. This assignment on page 92 is due on the homework check tomorrow, right? Okay. There are 3 questions on there, I think. 31, 32, and 33 that deal with this, that I have up here on the screen, that deal with this regression equation stuff, okay? All right. By the way, I haven't still decided if I'm going to be here tomorrow or not. If I'm not here and there's a video to be played by a sub, I won't know if you don't turn your homework check until Monday. Just telling you, because I won't be here. But don't tell any other class that, okay? Because I will be here until 6th period tomorrow. Okay. Okay. No, it's fine. It's fine. They're not going to watch this anyway. Only people who are gone are going to watch this. All right, guys. This is review of when we did linear regression. We're going to do other kinds of regression now. Did we do a little quadratic regression? Can't really remember. But we're going to put all these, we would normally. We're not going to do this one because there's way too many points. We would put all these in list 1, and then we'd put all these in list 2. We'd turn on the stat plot. We'd look, do a zoom 9, and get something like this, okay, this shape. Then they did a power regression, which is not a linear regression. And then they used that, they stored it. We're going to have to remember how to store it. And then they used it to make a prediction. It says the metabolic rate for a 60 kilogram animal is about 1,500 kilocalories. Okay. So, what you need to remember today before we start is how to find y1. Do you remember where that is? You have to, not how to get it on your screen. So you have to go the vars key. Do you remember this? Vars, arrow to the right, enter, enter, to find the y1. Okay, we don't need that right now, but that's the part that tricks everybody up. Ready? All right, so to start this is the question off your notes. To start this question, we're going to enter the data into list 1 and list 2. Then we're going to turn on the stat plot and do a zoom stat. That's all for part A. So we go stat, enter. I have it here. Okay, stat, enter should get you to this screen where you put in the data. And then second y equals, we're going to turn on the stat plot. I'm a cheater, pumpkin eater, so I have mine in already. Okay, does anybody not have a list 1 and list 2 because somebody's deleted them? You have? If you need to clear a list, you go up arrow and then clear enter. Don't hit delete or you've gotten rid of list 1 and list 2 and then you have to do some other things. Oh, you're right. I need to enter the data. Yep. Anybody else got a question?
I already have something in my plot. Or is this what it's supposed to look like?
That's probably what it's supposed to look like. Okay. I hear relatively little typing, so can I talk about how to turn the stat plot on?
Sure.
Okay. It's second, y equals. You want the first one to be on and the other ones to be off. We had a little trouble earlier today with people having multiple plots on. So you're going to hit enter, enter to turn this first one on, and you want it to be a scatter plot, which is this one, and then list 1, list 2, and whatever kind of mark you picked. Everybody okay? Second y equals, enter, enter. Make sure it's this first choice, not any of these other goofy looking graphs, just the first little dots. List 1, list 2. All right, then we need to do a zoom stat. Oh, wait, before you do this, go to y equals and make sure you don't have any craziness typed in. Okay, because otherwise you get like parabolas and graphs all over the place on top of your little dots. So if you have all your y1 clear, your y equals cleared out, then do a zoom stat, which is zoom 9. Zoom 9. Did everybody get this? I need to know right now who does not have this graph.
No, that's no. Well, that's your problem.
I'm very clear. I was gonna say I like your sweater, but instead of paying you stuff, you swear.
Okay. All right. Notice this is not looking like a straight line this time, guys. Okay? So it is some kind of a power function. It does look like part of a parabola, and you'll see in a minute that's kind of the equation we come up with. But the problem said to actually do a sketch, and this is when you do those 3 on your homework, this is how complicated of a sketch I want, okay? Just a bunch of dots, I'm happy. Just so you got the right shape. Now it says to do the power function, okay? Please be paying attention here. You need to do the power regression, which is, hang on, let me get to the right screen. It says here, go stat, right arrow, power regression, okay? Let me show you where I have captured a screen with that. It looks like this. It is choice A, way down. If you go stat, right arrow, and scroll down, 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 down. Stat, right arrow, and my calculator is really slow, or fast, because it just went past it, I don't know. Did you find power?
What's the difference between power? Like, what exactly is power?
Power regression means it goes through the origin generally, and usually it goes up this way. It can actually do different shapes because it can,
It's just like not a straight line.
yes, okay. We're going to talk about some more of these shapes tomorrow, actually. All right, power regression. If you have an older calculator like this one, or a all black 83 or 80 something, you need to go parentheses, second 1, comma, which is above the 7, second 2, comma, which is above the 7, and then vars, arrow to the right, enter, 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 and you'll finally get an equation. If you have the newer calculator, when you go to stat, right arrow, and scroll all the way down there, it brings you up some hints, right? It brings you up this, and it should already say, hopefully, list 1 and list 2. So the only thing you have to do is go down to store regression equation, okay? And then go vars, arrow to the right, enter, 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 till it does calculate and comes up with your equation. If you don't, yeah, what? I don't care. Y1, Y2, Y3, doesn't matter. Just one of the Y equations, you're going to store it. Okay? So you need to write this down on your paper. Let me go back here.
What are we going to
It's y equals ax to the b. So we have y equals, I'll be right there, 0.043, is that right? Or 432 or something? X to the 1.998. I've done this 3 times today. Does that sound right or not?
I thought 0.042. Yeah.
042? Okay, that's probably right. I forgot.
Good, good.
Oh, that's not that important for today, but it's under mode. You can scroll down here. See if you can go to catalog, second 0, and then scroll down and do diagonal. Here, what do you have? Here. Okay.
Some witchcraft, guys. We need to start. What's it called?
All right, so it was 0.042, not 32, right? What's up? Okay. Anyway, that's a big mess. All right. I'm going back to this, guys. This says here, a polynomial function with rounded coefficients will produce estimates different from values calculated using the unrounded regression equation. From this point forward, you can assume that when you are asked to do a model to estimate a value, they are asking you to do the unrounded, which means stored, equation. So to do that, here we go. To use the unrounded or stored equation to predict the value, we're going to use Ask Auto feature. Do you remember? It is here. It's under second window. Second window. And it doesn't matter what numbers you have at the top. Just go down to independent and change it to ask and make sure dependent says auto. It's not going to do anything with it. Now go second and graph. And then you want to type in an 80. If you already have numbers there, it doesn't matter, okay? But type 80, enter. And does everybody get 267.28? Okay. Can you do one more thing for me? Can you go to the home screen? So quit. And put 80 into this equation and see how close you get. So go 0.042 times 80 to the 1.998. Okay, the rounded one gave us 266 and the unrounded one gave us 267 point something, okay? Not that far off. This is stopping distance in feet at 80 miles an hour. I could spend the rest of the period talking about how important it is to understand stopping distance and the speed you're going in regards to accidents. I have 3 kids, they've all had accidents. I've had several, okay, yes. But we're just going to move on. But that 1 foot difference between 266 and 267 could be the difference in hitting someone in front of you, right? All right. That's pretty much it on this example. You have 3 questions on the homework to do on that. They're 31 through 33 here. Any questions? Do you need me to go back over any of the buttons? Do you need me to write anything down? Yes. Yes. Okay, so that part where we did the Ask Auto. Did you store the equation? You haven't put an equation in. You have to have stored it in here for it to work. That's the questions where you have to do the regression equations. Okay? All right, worksheet 3. Quickly, moving on to worksheet 3. All right. Just kidding. Why isn't it going? All right. We talked yesterday about monomial functions. They had only one term, right? They might have been stretched or go in funny directions, but they all went through the origin except for the rational one, and they had only one term. There was no shifting up, down, left, right. Today we're going to talk about polynomial functions, and we're going to do a whole bunch of talking about even and odd. Okay? Review of vocabulary really quick. A polynomial function is something when written in standard form might look like this. That's a hot mess, right? Standard form means that the exponent powers are getting smaller as you go left to right. Does that sound familiar? How many terms does this have? This is all about vocabulary right now. 1, 2, 3, 4, 5 terms, okay? This is a constant, but it is a term. All right? This is a degree 4, okay? The highest exponent power is the degree. Okay, if you put it in standard form, then it will be the first term, and that coefficient is called the leading coefficient. If it's not in standard form, the leading coefficient is still the coefficient of whatever was in highest exponent power. A polynomial function is anything that doesn't, that when you graph it, it is defined as continuous for all real numbers. In other words, the domain is all real numbers. It is smooth with rounded turns. It has no breaks, holes, gaps, asymptotes, sharp corners, any of that. Okay? There's part of the homework that just says, is this a polynomial function? It shows you a graph. If it's a smooth curve, it's a yes. If it's got a gap, an asymptote, a break, a point, sharp turn, it's a no. That seemed like a pretty easy part of the assignment? Okay. We have already talked about these polynomial functions. Yes, quadratic equations we graphed, lines we graphed, those are all polynomial functions as well. All right. Recall that graphs of even degree resemble the shape of a parabola. They either go this way or this way. They could have a bunch of little kinks in the middle, but the end behavior is both ends up or down. Well, anything with an odd degree is this shape if it's positive, this shape if it's negative. Okay? These are just talking about slides. I'm going to go super fast because I don't even know if this is on your homework. It might be. This is a degree 5, so it's this shape. And this -2 would shift it which way, guys? Okay, so instead of this being the origin, it would be over to the right a couple. This one is a degree 4 with a negative, so it's like going this way, but it's been shifted what? Up 1, so it's up here. This one is a negative x cubed that's been shifted up which way? Or it's been shifted which way? Up 4. So it's up here. Normally a cubic looks like this, but this negative makes it go this way. Degree 4, it's a U shape that's been shifted where? Left 7. It'd be over here somewhere. Okay. This slide just reminds you that if a polynomial is not written in standard form, you want to rewrite it in standard form. Otherwise, the term leading coefficient wouldn't necessarily be the first term. So if I write this, what's the leading coefficient actually? -8, because the degree is 3 that's here on this. If it was written in standard form, that would be the first term. We okay? Understand standard form, leading coefficient, degree. So far, so good? Okay. That degree determines end behavior. So if we have an odd degree, so it's degree 3, degree 5, okay? The ends will be pointed in opposite directions. When it's positive, left end down, right end up. When it's negative, left end up, right end down. This all sounds familiar? Degree that is even, like an x to the 4th or an x to the 6th, both ends will go the same direction. If it's positive, they'll go up. If it's negative, they'll go down. Let's put that in our handy dandy little chart here. This says even degree positive leading coefficient. So y equals 5x to the 4th minus x plus 2. I'm just making up some garbage. What would happen? That one is degree 4 with a leading coefficient of positive 5. So both ends would be up. It might do some garbage in the middle. It might not. Even degree but negative leading coefficient might look like negative 2x to the 6th minus 0.01. Just being a pain in the neck, okay? So it is degree 6 with a negative 2 as the leading coefficient. So it would go both ends down. May or may not have some gobbledygook in the middle. That one wouldn't, but all we're looking at is end behavior here, guys. When they talk about shape, we want the correct end behavior. All right, odd degree positive leading coefficient might be as simple as a 4x cubed minus 2x squared plus 5. That is what leading coefficient, guys. Leading coefficient is positive 4. The degree is 3. Okay, it would be a shape like this. Left end down, right end up. Odd degree, like a degree 5. With a negative leading coefficient, oh, I'll just be lazy and put a -1. Okay, so this one is degree 5. The leading coefficient is just -1. What does it do? What's the difference between the last one and this one? Yes, it's flipped. May or may not have some gobbledygook in the middle, but left end is up, right end is down. Did you do that stuff last year?
Yes.
Okay. Now we need to talk quickly about the difference between even and odd degree, even and odd function, and I'm going to throw in here at the same time to try to save time, even and odd multiplicity. All right, this is the deal. Even or odd degree is your highest exponent power, okay? So the question is it an even number or an odd number? This, that together with the leading coefficient, determines the end behavior. What else does it do? It also determines the number of zeros. right? If it's a degree 4, it crosses the x at most 4 times. Does that sound familiar? Right? If it's a parabola, degree 2, it can cross the x at most 2 times. Are you with me here, guys? Okay, we're going to talk about that in 1 second anyway. Even and odd function, what was that all about? Symmetry, yes, somebody said it. And even meant what? Y-axis symmetry. It did mean all the exponents of the polynomial would be even. But it meant the graph would have y-axis symmetry. Odd meant it would have origin symmetry. Remember, x-axis meant it wasn't even a function. All right. Even and odd multiplicity has to do with when you have a factored polynomial. The number of times the 0 repeats. So this is a 0 of multiplicity 1. This would be a 0 at 3 of multiplicity 2. And this would be a negative 1. It has a 0 at negative 1 of multiplicity 5. Talk more about this in just a second, but do you see what I'm talking about? It has a 0 at 0, 3, and negative 1. Are you okay with that part? 0, 3, and negative 1 being the zeros? Because that's how the factors set equal to 0 would solve. And then the multiplicity is how many times does it repeat? This is there once, twice, 5 times. All right. That determines whether it bounces or crosses the x-axis. I'm previewing what we're going to do in 1 second. It has a 0 at here, here, and 3. This is a total degree of 8. So it would come from up here. But because this has an even multiplicity at negative 3, it actually bounces back up. Has a little mini parabola there at 3. That's negative 1. I lied totally. Okay. At negative, this is negative 1. It should be crossing. At 0, it should be crossing. But over here at 3, because of this even multiplicity, it doesn't cross, it bounces. And that's not a sharp corner. I'm just kidding. All right. Talk more about that in a second. But I don't have any place else for you necessarily to write that in your notes, the even and odd business, so I'm putting it here. Everybody okay? All right, back to the end behavior thing really quickly. This is a degree 4 with a leading coefficient of 2. It's a positive 2, so both ends are up. So we write as x is on the left, y approaches infinity. As x is on the right, y is approaching infinity. Everybody okay? It's already in your notes there, right? Done for you? All right, can you tell me this one? Degree 4, leading coefficient. What's it look like? Both ends up. Okay? This one, be careful. Why do I say be careful? It's not in standard form. So it is 1 up and 1 down. Normally it would be this shape, but the negative out here does what? So it's left end up, right end down. And it may do some hinky stuff in the middle, but left end is up, right end is down. All right. This is the last vocabulary word today, is turning points. Maximum and minimum points are called extrema, and altogether they're also called turning points. A turning point, it says, is when the function changes from increasing to decreasing. Does everybody understand that as it changes from increasing to decreasing, it turns somehow, right? Now, if this is a degree 3 because it has at most 3 intercepts, right? How many turning points does it have? So degree 3 was 2 turning points. This has at most how many places it crosses? 1, 2, 3, 4, 5. So this is at most degree 5. and it has 1, 2, 3, 4 turning points. This has at most 1, I'm going to go with 2, 3, 4. So this might be a degree 4. And it has 1 maximum, 1 minimum, 1 maximum, so 3 turning points. What do you notice? It's 1 less, okay? So can you find somewhere in your notes, I know I didn't leave a spot for this specifically, but the degree is equal to the maximum possible number of zeros or x-intercepts. The degree minus 1 is equal to the maximum possible number of turning points. This is a really key concept that I didn't write a very nice spot in the notes for, okay? It's degree equals maximum number of zeros. Write it as short as that. And degree minus 1 equals the maximum number of turning points. Okay, maximum number doesn't always have that many. Everybody all right? All right, I just want to clarify a little more vocabulary. X-intercepts were also called zeros when we did them on the calculator. Remember we used the function that was called zero? Find the zeros. A x-intercept or a zero, when you set the equation equal to 0, is also called a solution. And if you factor it, it's related to that factor, right? So if I give you this, this is the factored form. The solutions are at 3 and -5, which means there are x-intercepts at 3 and -5, and those are also called the zeros. Just trying to tie all that together, but they're all related. All right, here we go. This is on your notes, and it's kind of worked out for you, so I'm going to go kind of quickly. It says state the number of possible real zeros. What's the degree, guys? Degree 3, so it has at most 3 zeros. And at most 2 turning points. We good with that part? But then it says find them by factoring. That's the part I want to spend just a second on. When it has 4 terms, what is our favorite method for factoring? Grouping. Everybody okay? That's what I would call it anyway. Out of the first 2, we're going to take an x squared. We'd be left with an x plus 2. We need an x plus 2 back here, so what do we need to take out? A -1. Then when we take out that x plus 2 and write it down, what's left to smush together is x squared minus 1. Are we done? No, this factors again, right? So we end up with the completely factored form here, which means the zeros were at -2, -1, and +1. You could list those in any order. Everybody okay? All right, now we're going to do some crazy business. Or not. What degree of this one, guys? Number 4A. You have this in your notes, I think. Degree 4. So number of possible real zeros, the maximum number of possible real zeros is 4. The maximum number of turning points is 3. This is a strange question because it only has 3 terms with a quartic term or a 4th power, a 2nd power, a quadratic term, and a constant. We can factor this. Do you remember how this factors? If I pretended this was an n squared squared, and this x squared was just an n, this would factor like -6 and -3, right? So we just have to do that with an x squared and an x squared, and a -6 and a -3. Kind of foil that back together in your head and make sure that makes sense. X squared times x squared to be x to the fourth. A minus 6x squared minus 3x squared to give us the middle term. We okay? All right, so that is the factored form. Whoops. Factored form, x squared minus 6 times x squared minus 3. We need to find all the real zeros. If I set this equal to 0 to find the zeros, I want exact, not from the calculator graphing zeros. What are we going to get? X equals square root of 6 and x equals square root of 3. Are there only two? Plus or minus square root of 6 and plus or minus square root of 3. Now, they tried to tell me that was only 2 earlier today, so I'm going to list them like this so we're clear. You don't have to list them like that, but everybody understands that that's 4 actually. Okay, moving on. Number of possible real zeros based on degree over here. 5 and turning points. 4. What can we do to factor that one? Take an x out. Good call, somebody. Then what? Do the same thing. Factors of 16 that make 6. Minus 8 and plus 2. So that's the factored form. Does not factor further. All right. Be careful. We have to set each one equal to 0. This one would give us a 0 at 0, yes? This one would give us zeros at, how does that simplify, guys? 2 squared 2. Anybody need me to practice simplifying that? You okay? All right. What about this one? X squared plus 2 equals 0. X squared equals negative 2. X equals... Okay, but what did it say in the directions? Yes, these are not places that the graph will cross the x-axis because they're not real zeros, so we don't have to worry about them. Everybody all right? Can I skip this question, guys? You would just graph it on your calculator. It looks something like this, and then you would tell me the end behavior. I guess I'm not skipping it. You get the idea, though? I don't really care about super accurate graph, and it only asked about the end behavior. How did I know that? That would be the point. Degree 5 with a negative leading coefficient, right? You could graph it on your calculator and just do a rough sketch, okay? I'm going to skip this one for right now because I want to talk about multiplicity. We talked about this a minute ago, but when a 0, it says up here, x minus c to the power of m. If x minus c is a factor of the polynomial, that m is called the multiplicity of the 0. If it has an even multiplicity, it's tangent to the x-axis. It touches or bounces or kisses. Some teachers use any one of those 3. Okay? It just hits the x-axis and bounces back off. If it has an odd multiplicity, then it crosses the x-axis. Non-repeated zeros have a multiplicity of 1, which is odd, so they cross. So I'm going to do one real quick here. What are the zeros? Negative 2, positive 4, and 0. If I multiplied this out, I would have an x squared, and an x cubed, so that would be a total of an x to the 6th, or degree 6. So it's coming from the top. What does it do at negative 2? It's a multiplicity 2, so does it cross or bounce? An even multiplicity, it's like a little mini parabola, okay? Bounces off. Then at 0, it's a multiplicity of 1, so it crosses. At 4, it's a multiplicity of 3. It's odd, it crosses. It actually would do a little baby cubic shape like this. It would kind of do a little kink there, but it would still cross. All right, we're going to practice this. This is a weird one. It says apply the leading term test. So we're just going to look at the leading term of each here. That part, we're going to look at this as a power of x, and this one back here is cubed. So we have a 3x cubed. So we'd have negative 2 times x times 27x cubed, which is a negative 54x to the 5th. I just need to know that because I need to know what shape it is. What does that tell us? Yeah, it's a flipped odd, so it's going this way. Okay, so that was the end behavior. Part B is determine the zeros. It's all factored for us. Can you tell me where the zeros are at, guys? Does the negative 2 affect anything? If I say this is equal to 0, I just get 0, right? If I say this is equal to 0, I get what? 4. If I say this is equal to 0, I get 1/3. Now, I need to know their multiplicity. Was there an exponent power on that plain old x? No, so it's just multiplicity 1. What about this guy? It's also just multiplicity 1, but this one is multiplicity. All right, C says find a few additional points. That's what you have a graphing calculator for. Back in my day, we had to plug in some numbers and find additional points. Yes, I pretended to multiply it all out by just looking at the leading terms. So there was a negative 2x. This is once, so there was an x once. And this leading term is there 3 times, so there was a 3x 3 times. Then I kind of messed around and simplified all that so that I knew it was a negative of degree 5, so that I knew the shape. All right, guys, I'm sketching. Is it crossing or bouncing at 0? Crossing. At 4? At 1/3? Also crossing. So it's doing this. It might do a little funky shape there, but it crosses here. Okay, there was some funk. Okay, I'm going to skip B so that we can get to this other example. I want to do this one together. Wake up. I have a negative x. I have a 2x that would be squared and an x. That would be a negative 2x to the 4th. So what shape is it going to be? Both ends down. Where are the zeros at? 0 of no multiplicity other than 1. Negative 5/2 at multiplicity 2, because it's squared. And then there's a 0 at 3, because of this factor. If I graph that, it crosses at 0. At negative 5/2, what does it do because of the multiplicity? It bounces. And at positive 3, it crosses. Now this behavior showed us that it was coming from down here on the left, bouncing, crossing, crossing. This general shape is correct. It could totally go much higher or lower at those max and min points. I have no idea. When I didn't have a graphing calculator, this is how I had to learn to graph. If I wanted to know what was going on between 0 and 3, I had to stick some numbers in and find some points. Okay? You have a graphing calculator. But that doesn't mean that I couldn't ask you what is the end shape, what is the multiplicity, all that kind of stuff, or to do a couple questions without the calculator.
You could just find it